So, okay, what we're talking about is ionic compounds. Can you see it now? Oh, it's searching. Okay. So wait, we've got problems. Yeah. And it's going, oh, that thing wasn't all the way in. Now it's going to do it. Oh, crap. Okay, sort of see it. So I got these ionic compounds. When you hear the word ionic, okay, think of, this is what I want you to think. I want you to think of a metal plus a non-metal. And hopefully that's pretty easy to do, okay? But we got to spell, geez Louise, this is going to, okay, non-metal. I would also like it if when you hear that, you would also realize that metals are going to give up electrons and that non-metals are going to take electrons. So those two things, so they kind of go hand in hand. When you hear metal, it's going to be something that gives up an electron. I would also like you to realize that when a metal gives up an electron, it's going to form a cation. And when a non-metal takes an electron, it's going to form an anion. Okay, these are things that are going to go with us all through the entire year. We're always going to be coming back to this with ionic compounds. Something that isn't quite as important is that they are connected with electrostatic bonds. Okay? And when I say an electrostatic bond, it's just a positive smushed up against a negative, which then gets a positive next to it and a negative, and it keeps repeating in this order. Positive, negatives, positive, negatives, positive, negatives, like that. All right? I like the blue. Looks cool here, but I'll get rid of the blue. Okay, no more blue. Green better? Or would a white background be better? I don't know, maybe I can change it. Okay, but anyway, so it keeps, so last night in the video, okay, I said, well, these positive negative stackings can come in three varieties. You can have a simple cube, you can have a face-centered, and you can have a body-centered. And as it turns out, really these are the three ways that centered. Three ways that you can stack these positive and negatives together, okay? And that's sort of it. And there's not a lot more to looking at the structures of ionic compounds. They all sort of look like salt, table salt or sugar. If I go to my back room and I get an ionic compound, chances are 9 times out of 10 it's just going to be a white salt. And it could be, lead nitrate, it could be calcium chloride, but they're all going to sort of look the same. The ones that don't really look the same sometimes are the transition metals, because copper salts are green and cobalts are blue and irons are yellow. But that's because they have d electrons and the d electrons absorb light differently. But for the most part, they're all going to look like salt. And that's why ionic compounds as a whole are generically referred to as salt. So if you're talking about a salt in chemistry, you're thinking of something that is ionically bonded. It's a metal and a non-metal together. Now, when I drew these forms of the crystal lattice, here was the simple cube. Okay, it looks something like this, coming down around here, going up, going over to that, and looked like that. And behind there was another one. Well, this ion might be positive, this would be negative, this one would be positive, this would be negative, here'd be a positive, that would be a negative, and that's a positive. And that's how they're all stacking together. And they have three ways they can do it: face, body, or simple. Well, In reality, what that looks like, okay, is this positive is probably more like that. This negative, is bigger like that. So the positives are red, kind of like that, and the negatives are kind of like that. But you get this idea of how these ionic compounds are all going to be stacked together. And this inner part right here that I drew first, that becomes called a unit cell. And a unit cell is the simplest repeating little piece of that ionic compound. So right next to it, I would have another unit cell that would be looking like this, that would go up to that comes up to here, that would go like that, and then I would be repeating the positive there, and blah blah, and my picture starts getting really complicated. But this unit cell just repeats and repeats, 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 and repeats. Okay? So, that's the picture I want you to have of these ionic compounds. And it's really simple. There's not a whole lot of choice to it. What's more is when I'm talking about ionic compounds, the way they go together is pretty simple. If I talk about the metal lithium, and I talk about the nonmetal sodium, or no, nitrogen, and I looked up on the top of the periodic table, okay, and these are all going down in columns, blum, blum, blum. The top of the lithium, hopefully I have a 1. I'm not sure why it's not drawn, but hopefully I see a 1 up there. Oh, did I lose the whole shebang? And we have some technical difficulties once in a while. Do I have a 1 up there? Okay, can you see the 1? I gotta move the screen down if I'm gonna do this. Is that better? Okay. Above the nitrogen, you should have a 5. You see what happens sometimes. 5. 5. Okay. 5. Okay? Got some problems. That means I'm getting out of red. I don't like it anymore. If I'm going to draw lithium, it gets 1 dot because of the 1 that's at the top, the 1 valence electron. If I'm going to draw nitrogen, it gets 5 dots. 2, 3, 4, 5. Alright? Now what lithium is going to do, like all metals do, it's going to give up its electron. When it loses its electron, it becomes a positive cation. Nitrogen is going to do what every nonmetal does. It's going to go to a nitride ion, which means it gains 3 electrons. So it's going to gain 1, 2, 3. In the process of gaining 3 electrons, it becomes a negative charge. So there's not a whole lot of ways that ionic compounds can go together. Lithium has 1 to give. Nitrogen has 3 to take. So how I'm going to remedy this whole thing is I am going to need 3 lithium ions and 1 nitrogen ion. Not sure what happened with that. Okay? And when those go together, I would write it in a compound as Li3N. And that's where we're going to end with ionic compounds. Okay? Sort of get to this point. We're going to do this a lot more, but what I want you to kind of know is how those electrons are rearranging themselves. And when you think about it, there is a finite number of ionic compounds. I look up at the periodic table, I have a whole bunch of metals, a few nonmetals. They can only go together one way, and it's real specific. One has to give, the other has to take. I can't say, okay, what happens if I have 4 lithiums? 4 lithiums and 1 nitrogen. No, it doesn't work that way. It has to be 3 lithiums and 1 nitrogen. And what that does is it really limits the number of possible ionic compounds that you can have. We're going to leave ionic there. The next thing in the installment, but this is going to give me trouble because this is about ready to stop, and so I'm